Hello, good afternoon, everyone. How are you doing today? It's good to see all of you. Let's just get to join. I'm expecting more people. I hope we're having a great time this holiday period. Um, Basically, today is going to be one of those days that you I've always looked forward to, you know, getting to study organic chemistry. It's really very interesting. In the past, as a student, I don't know how much opportunity I had to study organic chemistry. But the few time I studied organic chemistry as a student, perhaps I understood some. Maybe I understood others, but the secrets of organic chemistry I never knew what it was all about. But today, over the years, teaching students, obtaining higher degrees, has really, really improved. I've actually learned a lot. Before I understood organic chemistry, even as an undergraduate student, I studied chemistry in university. So it was quite difficult, you know. And um, what can I say? I can only thank God anyway for learning chemistry or studying chemistry in university and understanding the core secrets of chemistry. All right, so today we are going to look at a very, very interesting concept. That's organic chemistry. In the past, in Weac, they used to have a whole question on its own, you know. But over time, so in, in the past maybe 5, 6, 7 years, um, you could actually escape organic chemistry without attempting it in the exam. But in recent times, between last year, 2 years ago, 3 years ago, one thing what the WAEC is doing is that they do not make organic chemistry to be a question, a topic on its own. They infused it into other questions. So you may have organic chemistry in question one, organic chemistry in question three, organic chemistry in question five. So there, of course, in the objective also. For those who have not written JAM before, or those who wrote JAM in the past, you discover that they have a lot of questions. In the past, while I was attempting JAM, I usually after my scouting, I will see that there are 10 questions. There are 10 questions in organic chemistry in the objective section, both the theory and objective. So both for objective. So 10 questions in the objective for WAEC, 10 questions in the objective for JAM. So if you're able to come across those stuff, if you're able to do well in them, you definitely know that chemistry is beans. And one thing I always encourage students to do is if you understand bonding, again, that's another thing. You understand bonding in chemistry, then you can actually understand organic chemistry. I can't lie. Remember when we did electrolysis, I took you back to ionic bonding. Yes, I took you back to ionic bonding. But here in organic chemistry, I will take you a little backwards to covalent bonding. The covalent bonding is the type of bonding where an element shares electron with another element. Okay, so in covalent bonding, the the two combining elements usually share electron. Okay, so let me just share a screen for you to see what I'm talking about here in covalent bonding. So let's look at this chlorine atom here. So when electrons are shared the two participating elements contribute equal number of electrons. So when they contribute equal number of electrons, so you can see here that you see the electron from the two chloride atoms are 1 1 each. So when they share, they form a molecule, chlorine molecule. You can see the bond. That bond is a covalent bond. So having learned about covalent bond occurs in mostly all carbon compounds. All carbon compounds contain covalent bond. Okay, so without wasting much time, I know we have 1 hour of chemistry. I'll show you that I'm going to this chemistry. This organic chemistry is actually very, very wide. When I say wide, I really mean very wide. So you can have organic chemistry into organic chemistry. You can study organic chemistry for a whole term in secondary school. I remember one of those days as a teacher, I decided to leave organic chemistry. I didn't touch organic chemistry in SS2. Or we didn't touch organic chemistry in SS2. So we used the whole of first STEM SS3 to do organic chemistry. And yet, we did not finish. Yet we did not finish it. So we still had to carry it to SS3 second term, So, but I'll show you, we are not going to do a lengthy organic chemistry thing. I try, most of the things I'm going to do, I'm going to, so you have to write on your own. So please ensure that you write. If you're able to write, then you definitely can get everything that we are going to do. Okay, so without much wasting of time, let's go straight to the business of the day. Good afternoon, everyone, gentlemen and ladies. I'm excited to have all of you here. And please, for this session, ensure that you use the chat section for questions. If you have any question, you have anything you want me to emphasize again or repeat, or you did not understand, I will go over it. I don't have struggle repeating things, so that as long as it's for you to understand me better, okay? So organic chemistry, I just have to put this simple definition. It's the study of compounds containing carbon. It's as simple as that. It's a study of compounds of carbon. Okay, where do we get organic compounds? Crude oil, coal. So I put oil here. So this oil could be crude or can be oil from plants, oil from any source. As long as it is oil, it contains organic. But technically, what I'm talking about here is crude oil. Okay, so other sources of organic compounds are plants, animals, and microorganisms. If when you go to let me just say, in Madagascar today, they say they got a cure for coronavirus. That is a plant extract. They only extracted some organic compounds and they tested it on the individuals and it worked to some extent. So that means those compounds, and what WHO, they are calling it organics instead of calling it locally made drugs. They now call it organics. The reason why they are calling it organics is because they've not even separated it. They've not gotten the main component that is responsible for curing that coronavirus. So that's why there is a challenge. Is it possible? What if you don't have plants anymore? Is it possible for us to synthesize it in the lab? So that's why they don't trust it, because they don't really know what actually is the compound there. So they now start calling it organic. So when you talk about organic, it simply means from plants. So organic is a very, very big aspect of chemistry. So today we are going to try and take this organic down to one of the sections of organic chemistry. And so my focus today is on hydrocarbons. So hydrocarbons are compounds containing carbon and hydrogen. So you can see the word hydro and carbon. Hydro from hydrogen, carbon obviously from carbon. So any compound containing carbon and hydrogen only is what we know as hydrocarbon. Now, in I think that's 2012 or so, or 2011, there was this Weac question that state two sources of hydrocarbon. Where can we get these compounds called hydrocarbon? Two sources. So we have some common answers that we got from Weac. Crude oil is a source. Natural gas is another source. Coal is another source. Then, if you check the previous page here, I also talked about plants, animal, plants like in rice farm. In rice farm they produce methane. In animal dung they produce some organic products also, and in some other microorganisms. Okay, so we have some. So the first question that you see in WAEC, define hydrocarbon. That was 2018, 2017 WAEC question. 2012, 2011 question was state the sources of hydrocarbons. Okay. Who will I ever ask you classifications of? No, nobody will ask you to classify hydrocarbons into or state the class of hydrocarbon. But nobody, there's no stress about it. But I remember WAEC asking this question: what are hydrocarbons? You see that word? What are? So they did not say, they cannot say what is. So whenever you see that keyword, what, WHAT, it simply means that it goes beyond defining it. So if you define it and you don't explain it, then you will not get your full mark. But we don't do explanation in chemistry. If you define, you give an example. Define and give an example. So if you see a question, what are hydrocarbons? So that means you say these are organic compounds containing carbon and hydrogen only. Example, you give alkanes. You can see I've decided to classify my hydrocarbons into two broad ways. One, we call it aliphatic. Aliphatic, then the other one I call it aromatic. Okay, so the aliphatic are obtained from oil. They call it oils. And when you say aliphatic hydrocarbon, we simply say they are obtained from oil. So plant extracts, they are from oils. So that aliphatic is the Greek name for fat. So you have oils like paraffins. Paraffin is that chemical that they use in making candle. Okay. They use paraffin in making candle, shoe polish, not just them. So then we call aromatic. Aroma, sweet smell. So they have some unique smell. I don't want to say they are sweet smelling compound, but they have some unique smell. Okay. An example of such aromatic is benzene. You may not, for those of us who are just entering SS2, you may not have heard of benzene before, but so for this class you will hear of benzene. So benzene is the major body for aromatic hydrocarbons. Then so for aliphatics, we have three broad categories. There are subcategories, but I don't want to stress you with all those things. So we have, for aliphatic, we have three categories. We have alkanes, we have alkenes, we have alkynes. There's one word I use there, derivative. See, derivative. That's another one. You can say derivative. That means that it is obtained from. So obtained from. So if I say alkane, there's what we call a halogen. Halogens are group 7 elements. So I can say a derivative of alkanes are haloalkanes. That means alkanes with a halogen. So it's not a big deal. Haloalkenes means alkenes with a halogen. Okay, so there is no big deal. So under these hydrocarbons, we have three classes of aliphatic hydrocarbons. One, they call it alkanes. The other one is alkenes. And the third one is called alkynes. Now we are going to try and differentiate these categories of hydrocarbons. Remember, our focus today is on hydrocarbons. So to classify this, we are going to focus on differentiating these hydrocarbons. So let's look at the simplest way to differentiate them. The simplest way to differentiate them is depending on the type of bond they are present. Remember in that, what do I call it? In the covalent compound I showed you, we saw this kind of lines. These lines, we call them bonds. We call them bonds. So you can see this is a bond. So this is two bonds together. Then this is three bonds together. Okay. So this is a single bond. So if you see an organic compound, if you see an organic compound and you are only seeing this single bond, you did not see anything like double bond, you did not see anything like triple bond, then you know that that compound is a saturated compound. Let me repeat myself. If you see only chain like the bonds, single bonds throughout, single bonds between all the carbon atoms, when you connect all the carbon atoms together, and if they give you single bonds only, then you definitely know that that is a saturated. See the word here, saturated. Saturated meaning that the bonds were the shared bonds between the atoms were contributed singly by each of the atoms. So, or the shared electrons between the atoms are all made up of single electrons. So that means between this carbon and this carbon brought an electron, and this other carbon brought and also another electron. So when they shared, they formed a single compound. But when it is double bond, that means each of these carbon brought two electrons, and the two carbons are sharing two electrons. So in Weac, you need to take note of one thing. Weac has started upgrading their chemistry questions. So they will not be telling you that but I want to know if you actually know how many electrons were shared here. So if you look at between these two carbon and these two carbon, how many electrons were shared? One each. So there are only two electrons in this bond. In this one, each of them brought two. That's why I have double bond there. Each of them brought two. So that is why we have two bonds here. Okay, so the total number of electrons here is 4. The total number of electrons here is 6. So that's in the triple bond. So take note that I want to teach you one unique thing in chemistry. Now, the single bond have 2 electrons. The double bond has 4. The triple bond has 6. Imagine where you have more electrons for bonding. That means those ones that have more electrons, they have that tendency to combine with other elements. Take note, like chlorine has 1 electron in its outermost shell. It already has 7. So with that single electron, it can use it to bond. But looking at hydrogen bonding with any other element is usually limited. It has only 1 electron. So merely when it bonds with another element, so it will just form a single bond. That is why in all the compounds I'm going to be showing you, all the hydrogen are bonded to 1 bond like this. So anywhere you see, you can see, I can try to put hydrogen here. You always know that hydrogen has only 1 bond like this because it is sharing only 1 electron. I'm giving you the key things in organic chemistry. You see, hydrogen has only 1 bond. So you can see this hydrogen has only 1 bond, and that is this bond here. This bond here. So this bond is expecting hydrogen to be. That's why we are calling it hydrocarbon. But let's take a look at carbon itself. How many bonds can you see around carbon? Let me count. 1, 2, 3, 4. You see, carbon has 4 bonds. This is the secret for organic chemistry. If you want to understand organic chemistry, you need to understand what we mean by all these bonding. Anywhere you say carbon, it must be surrounded by 4 bonds. Check this out. This other one. This carbon is surrounded by 4 bonds. Remember, the bonds are covalent, meaning that the bonds are shared. You cannot say this carbon has only these 2 and it is not participating in this electron. No, it's participating in it. So that's why I say the bonds are shared. That's why it's covalent. Covalent means that the electrons are shared. So the bonds are shared. So anywhere you see a carbon in organic compound, 4 bonds. Check out this one in benzene. Each of the edges is carbon. This is carbon. This is carbon. This is carbon. this is carbon, and this is carbon. So this carbon is already, this carbon here is having one bond here, one bond here, one bond here. It's already having three. So to complete its bonding, it only needs one more bond. So for it to be a hydrocarbon, to bond with this hydrogen, to bond with this hydrogen here, it's to bond with this other this hydrogen here too. So at the end of the day, in benzene, we have 6 carbon and 6 hydrogen. So the secret of organic chemistry is knowing that every carbon must have 4 bonds. If you are drawing your own and your own now gets to 5, my dear brother, my dear sister, you are wrong. If you are drawing your own and your own is only 3, is incomplete, you are wrong. So key things is, I want you to take note. Hydrogen, how many bonds should hydrogen always bond to? Hydrogen should always bond with one bond. Oxygen must always have 2 bonds in organic chemistry. Carbon must always have 4. Please take note. Carbon must always, is a must, so no excuse. Nitrogen must always have, excuse me, I'm having something like my screen. But nitrogen must always have 4. Nitrogen must always, let me correct myself. Nitrogen must always have 3 bonds. 3. You are dealing with organic chemistry now. So anywhere you see in an organic compound, carbon must have 4 bonds. Nitrogen must have 3 bonds. Oxygen must have 2 bonds, and hydrogen must have 1. So if you are drawing your own organic compound and the bonding is not correct, my dear brother, my dear sister, no matter how much you do, if I'm marking your script in Weac, if you are expecting to have 10 bonds and only one of the bonds is not correct, there is no mercy. I can't lie to you. I don't, because the earlier you fail it, the faster I'll be able to mark those 100 and something or 200 skills that I'll be having from Weac. So actually, that's what it is. Whether you are doing IGCSE or whether you are doing Weac or whether you are doing your normal school exam, if your teacher is lenient, that's his own business. But trust me, I can never be lenient. I can only be lenient if and only if I'm led by the Spirit. But not this kind of. If I'm lenient with a student now, when you get to the exam, you can never know who is the person that you mark your script. So ensure that you don't forget that rule. Okay, so what I'm going to do here is that I'm going to skip a lot of. I'm actually because this is a general class. It's not a class where I have too many slow learners, too many fast learners, and I have to just take one slide, explain everything together. Just take note of those things I've told you. Hydrocarbons are divided into 2 broad. One is aliphatic, one is aromatic. The other, for our focus today, is on aliphatic hydrocarbons. Those aliphatic hydrocarbons, they are alkanes, alkenes, alkynes. How do we differentiate between alkanes, alkenes, and alkynes? Number 1, you use this general molecular formula, CnH2n plus 2. What does this depict? What does it mean? It simply means here is showing, when you do empirical formula and molecular formula. So empirical formula is showing you the simplest possible ratio. So while molecular formula is showing you the actual number of atoms of each element present in the compound. So look at how, when n is equal to, let's say 2, for an alkane, let's put that into the formula. An alkane becomes C2H6. You can see that's for alkane. So if you use that formula for an alkene, it will become C2H4. For an alkyne, that means we have C2H2. You can see the difference. Now it's very, very important that you follow this trend, because like I told you that all these organic products, organic compounds, they are from plants. There are plants. I really mean there are so many plants in your environment. There are so many trees, the different components of the plant different components found on the leaf, different components found on the stem, different components found in the roof, different components found in the way you extract them. That's what called a method of extraction. Maybe you can remind me of that maybe whenever we have class or maybe on WhatsApp. I will just explain those methods of extraction on WhatsApp for those of us that are on the WhatsApp group. When you talk about method of extraction, some people extract, there are different methods called cold extraction. You have what we call steam extraction. Then you have what we call gaseous extraction. But that's not your business. Why I could ask you, but the simplest thing why I could ask you, how do we get all these organic products from plants? One of the topics will be discussed is petroleum. Maybe we'll do it towards the end of hydrocarbons. Petroleum, where we have to do fractional distillation of crude oil. So remember that in SS1, when you do fractional distillation of crude oil, you get different products: petrol, kerosene, diesel, bitumen, lubricating oil, the growing. That's one method. That means we are using fractional distillation. Some other people use chromatography. Chromatography is method of separating what we call it soluble liquids, soluble solids from a solution. I prefer to use that word. I don't like using colors. Colors is for people that are looking for objective answer. If you say method of using colored mixtures, fine, you are correct. But we are talking about solids from a solution, things like dye, obviously they'll be colored. That's for chromatography. So there are different methods of isolating these organic compounds from their natural products. But that is not what we are interested in. I've already shown you we can differentiate alkanes, alkenes, alkynes. One thing you need to use to differentiate between these organic compounds is that alkanes, all the carbon. I didn't look at what I'm saying though. All the carbon. I did not say all the compounds. All the carbon. Our focus is on carbon. All the carbon are joined together by a single bond. That's why we call them saturated hydrocarbon. Saturated hydrocarbon. But for alkenes, at least, and alkynes and benzene, two of the carbon, minimum of two of the carbons are joined together by a double bond or a triple bond. That is what means that it is unsaturated. It becomes saturated when it is joined by a single bond, when all the carbons are joined by a single bond, but it becomes unsaturated when at least two of them are joined. At least two. I'm repeating myself here, at least two. That means for an alkene, we cannot have one carbon. For an alkyne, we cannot have one carbon. And for benzene, we cannot have one carbon. But in an alkane, we can have one carbon. So alkenes, alkynes are described as unsaturated, while alkanes are described as saturated. Okay? Now let's move forward on how to name it. Obviously, nomenclature means naming, okay, like a naming ceremony. So obviously today we are not doing naming ceremony. So let's see how we draw these organic compounds. Remember, our time is pushing, is fast being spent. Now, first thing first, let's see but2-ene. This is an organic compound. Look at the word here. It ends with an "-ene". That means it could be an alkene. But you are going to learn how to do it. This is what we mean but2-ene. But means it has 4 carbon. But means it has 4 carbon. But2 means the double bond, because it's an alkene, is on the second carbon. Is on the second carbon. Now, how do I know that it's on the second carbon? Ladies and gentlemen, boys and girls, I can start counting from my left or from my right. This is just for us to do. So this is what we call structural formula. When you get to a question, they ask you draw the structural formula. This organic compound that you are seeing here is what we describe as the structural formula. Here, we are just trying to write the molecular formula. This is what we call condensed. In Nigerian curriculum, we don't usually use this word condensed. But when you go to university, you will obviously see it. Or if you are going to study abroad, you always use that word. Okay? So look at see the way I draw the condensed water. This You can see this one carbon surrounded with these 3 hydrogen is written as CH3. This carbon here with only 1 hydrogen, you can see it here. You indicate the double bond because it's the double bond that makes it an alkene. This is another carbon with 1 hydrogen. This is what I put here. This is another carbon with 3 hydrogen. This is I wrote as CH3. Another way to express it is this. Look at what I've written. It's still the same thing. This is like a boat form. Look at another way I can write it. This is another way we can write it. You see, I'm trying to hide all the hydrogen little by little. I can decide to write it like this. So whichever way you are expected to, you should be able to understand this. Each of the edges, look at this edge here. Let me annotate. This edge means there's a carbon. You see this edge, there's a carbon and 3 hydrogen. That's what it means. This edge, there's a carbon. This edge, there's a carbon. This edge, there's a carbon. So they are the one that will fit in. But if it is in an exam condition, should I draw it my own like this? Please, in the name of God, don't draw it like this. During the exam, choose the method that shows all the hydrogens. That means, which method is that? This one here on my top left. That's one. Like I told you, if you mistakenly miss one, sorry is your name. Nobody has time to be checking. Okay, so it will score you 0. Okay, I want to show us another one. Look at this one. This is an organic compound CH3, CH2, CH2, CH2. You can see the CH2 they are repeating. We can decide to write it like this, or the one on the right hand side is still the same thing. So these are the different ways we can derive our organic structure. But let's learn how to name these hydrocarbons. We have 28 minutes to the end of this session. In the next 6 minutes, we'll go out, I'll have to log you out and we'll come back and log in again. That is in the next 6 minutes. So I didn't say we'll log out now. So because we have supposed to have it 1.5 session. Okay, so let's just proceed. When I log you out, please ensure to come back. Okay, so let's see how to name an organic compound. We are dealing with hydrocarbons. First, the name will end in an in, or an ein. In, or ein. Okay, depending on whether all the carbons, if all the carbons are connected with a single bond, it will end with an in. If you somehow see that there's a double bond there, that means it is going to be ending with an in. If you see a triple bond there, that means it's going to end with ein. That's how this is why n is on sound. Ein, kind, time. Okay, so that's the way it sounds. Now, there's also what we call a prefix. In English, pre, before. Okay, before you fix it. Prefix. I'm just joking. Pre means before. So before you write the n, we usually have what we call prefix. Prefix means there's also what we call roots. Root hydrocarbon. Maybe your school teacher must have talked about roots. Yeah. Root hydrocarbon is simple means the number of carbon atoms joined together, or number of carbon atoms connected along a straight chain. If the number of carbon atoms connected is only 1, my dear student, you only call it meth. The prefix becomes meth. If it is 2 carbon atoms together, it becomes eth. If it is 3 carbon atoms together, it becomes prop. If it is 4, boots, 5, pent. So after boots, you use the octagon nomenclature. Octagon, what is that called? Octagon. Polygon nomenclature. Polygons, 5-side polygons and above. 5 sides is pentagon, so we use pent. 6 hex, 7 hex, oct, 9 non, and dec. Instead of writing decagon, you can choose to call it decene, or decane, depending on the kind of bond that you see in the compound. Ladies and gentlemen, they are making brain, and you see what I'm going to talk about. If I were to ask you, if a carbon atom, if it's an alkane and it has 7 sides, what should be the name? Yeah, think. think and write it by your. If it's 7 sides, what should be the name? If it is an arcane, okay. Have you gotten it? Let me see my own answer. Okay, if it is an alkene, if it's an alkyne, what should be your own? If it is 2 carbon, what should be the name? Think. Write it down. I'm going to ask. I'm going to check. Check another one. If it is an alkene, if it is 1 carbon, what should be the name? If it is 3 carbon, what should be the name? Ladies and gentlemen, you have 5 seconds to get the names on your own. You may want to share it by posting it on the chat session to see if you got it. But let's just, because of our time. Yes. Did you get it? Heptane and nonane. Heptane and nonane. So if it 7 sides is heptane, 9 sides is nonane. 2 sides, ethyne and butane. Did you get it? Did you get it? Okay, yeah. Nice. Okay. Then next one. Somebody wrote methane because it has 1 carbon. And propene. Wow, if you did get methane, God bless you. You missed it. I told you that alkenes and alkynes cannot have 1 carbon because there must be at least 2 bonds to join them together. There must be at least 2 carbons to join the double bond or the triple bond. So there's nothing like methane, okay? I just use that to confuse you a little. Thank you. All right, so all right, nice. Thank you. Okay, so that this demonic I discovered recently, you can use met for methane. Okay, let's see what we can use. Let's see. Yeah, just for fun. So if you want to try remember the first 4, let me tell you, if you're writing Weac, you need to know first 5 actually, maybe first 5. If you are a JAMB student, no stress. You can know as many as possible. Okay, so that's monkeys eat peeled banana. So P for starting with propene. Okay, just for you to, if you can try and get this one. Yeah, this pentagon shape. Okay, so you can try to use octopus like octagon if it is 8 sides. Just for you to have fun. Okay, so decimal, decane, decathlon. Okay, anyone you like is good for you. Okay, so what I'm going to do, I will log you out now. You please don't go away. The class will end by 4 p.m. So log in again. All right, so I will continue the ending part of this lesson.